Hi guys. So the last video that I posted for you was about solving log equations. Um, we spent some time going over logs, log properties, and then solving equations. So just to kind of refresh your memory, when we have a log, unless otherwise stated, it has a base of 10. So let's say that we have log base 10 of y equals x. So one of our main properties that we ended up using was this idea that logs are your bay, right? Um, what that means is base, answer, exponent. So we were able to rewrite this as 10 to the power of x equals y. So that was a really important property, and that allowed us to kind of rearrange so that we could better solve our equations. So, what we're going to look at today is something called the natural log. And we talked a little bit about it when we learned about our money equations. Remember, we had the formula PERT. So, natural log is denoted by LN, and natural log goes hand in hand with the number E. Okay. So, one of the things that we need to know about a natural log is when you have a natural log equation set up, okay, over here with log, when there was no base with it, we were working under the assumption that it had a base of 10. So, when you see a natural log, you are working under the assumption that a natural log has a base of E. So, how I told you to get into the habit of filling in a base of 10 for logs, you're going to fill in a base of E for natural logs. Because then what you can do is you can still use this little bay property. So you have a base of E, an exponent equals an answer. And if you remember on the graphing calculators, our natural log button, then we have this E. So if we hit second natural log, it gives us E to some power. Now, what I will do also is I will look around at some of the online calculators because I understand that, you don't have the graphing calculators at home. So I'll look around at some of the online calculators and I'll try to post something with how you can use the online calculators to do this a little easier. So, big thing, we're going to jump right into solving natural log equations because all of the properties that we learned about logs all still apply for natural logs. So we don't have to go over the properties again. So if you forget those properties, maybe revisit some of those videos that we watched. Now, these first few examples, 1 through 4, these are kind of like what we saw with the interest formulas, PERT, because E was already in the equation. So these should not be too terrible. And what you can do with these is once your E part is all by itself, you can take the natural log of each side. Because one of the things that we talked about is natural log and E. When you put those together, natural log and E, that is equal to 1. So 1 doesn't do anything for us, so it just kind of goes away. So what we're left with is the x and natural log of 18. So in order to solve this problem, all I have to do is type in natural log of 18. So I get x equals 2.89. Okay. For example number 2, you have to get the E component by itself first. So that means the first thing I have to do is I have to move the 4. So I'm going to have E to the power of x over 5 equals 3. Now this problem is very similar to number 1. So what we can do is take the natural log of each side. Natural log and E go away. So I have x over 5 equals the natural log of 3. Then if I want to get x by itself, remember you're just always doing the opposite. So in order to get x by itself, we see that they are dividing. So we are going to multiply both sides by 5. So the way that would look in the calculator, I would do natural log of 3, close that parenthesis, then I can multiply by 5. So 5.49. On number 3, the E part is already by itself. So what you have to kind of think about is this gets grouped together. So when I take the natural log of each side, the natural log and E go away. So I have this whole thing left. So I have x plus 1 equals natural log of 30. So in order to get x by itself, I'm going to have to subtract 1. Now, the most common mistake that I see here, and it happens over here also, when we multiply by 5 on each side, notice that we did not do 3 times 5 and do natural log of 15. You have to deal with this first, then times by 5. Same thing here. You have to deal with this first, then subtract 1. So you can write it as natural log of 30 minus 1. So it's going to look like this, 2.4. Okay, hang on, guys. There you go. Okay, so at this point, you should be able to do number 4. So you can pause the video and copy down number 4 and try that. I'm going to go ahead and do it. So that way when you unpause, you can see what it looks like. Sorry about the kids yelling, guys. We got superhero action going on in there. Okay, so hopefully you were able to work through that problem. So now what we've got, okay, so for these last 5 problems, this is going to be something kind of different, or different from the first ones anyway. So these are very similar to the log equations that we solved. Now, if this was just a regular log equation, the first thing that I would tell you to do is fill in the base. So since it's natural log, the base that I'm filling in is E. Sorry about that, guys. I got crazy kids. Okay, so once I fill in the base of E, then I can use Bay, and this 3x goes together, okay? So I have a base of E, an exponent of 6 equals an answer of 3x. So what I would do at this point is in my calculator, I want to figure out a value for e to the 6th. Now, I'm not going to write that down entirely because remember, a lot of what we want to do is use the calculator so that we're not rounding. But it's 403.4-ish equals 3x. So now to get x by itself, I have to divide both sides by 3. So with all of this still in my calculator, I'm going to divide by 3. So I'm going to give the final answer as 134.5. Okay. So very, very similar to what we did with logs. Fill in the base, use Bay, solve from there. So number 6, fill in the base. I'm going to use... This is my answer. This is my exponent. So when I rewrite this, I'm going to have e to the power of 36 equals 4x minus 1. Now, a lot of this you can just do in the calculator without writing your steps out. Okay, so for the rest of this problem, I'm actually not even going to write anything down. I'm just going to think about what steps we would do, and I'm going to do it all in the calculator. So the first thing I'm going to do is e to the power of 36. And we get a huge number. It's 4.3 times 10 to the 15th. So then if you are thinking about solving this problem, imagine this is just a regular old number. What would you do next? The next thing that you would do is you would plus 1 to get rid of that. Then you're left with just the 4x. So you would then divide by 4. So we end up with kind of this weird answer. X equals 1.08 times 10 to the 15th. So that would be kind of a pain in the butt to write everything down every time when you end up with such a big, weird answer like that. So this one is best to just work through in the calculator. Now, moving on to problem number 7. I'm going to put my base in. So then I'm going to have base, answer, exponent. So this is going to be e to the power of 3 equals 4x squared. So at this point, you guys should be able to do this problem. So, go ahead and pause the video and try this problem on your own and see what you come up with. I'm going to go ahead and work through it. So when you unpause, you'll be able to see me working it. So I'm going to do e to the third. So I've got about 20.09 equals 4x squared. The next thing that I have to do is divide both sides by 4. So keeping that in my calculator, I'm going to divide. So 5.02 equals x squared. To get rid of a square, hopefully we remember we have to take a square root. So in my calculator, I'm going to take the square root of the answer. So I have x equals 2.24. So now for the last two problems, these involve the different properties that we talked about with logs. So for number 8, we see a minus, and hopefully we remember that minus goes hand in hand with division. So the first thing I'm going to do is rewrite this as one natural log, and these two things have to be divided. So I have natural log of x plus 2 divided by 4 equals 3. Now this problem becomes exactly like the others. I'm going to put in my base. I'm going to use bay, and I'm going to rewrite. So e to the third equals x plus 2 over 4. And I'm going to start doing some work in my calculator now. So e to the third, I've got that 20.09. Equals x plus 2 divided by 4. They're dividing by 4, so I'm going to multiply both sides by 4. So in my calculator, multiply that by 4. So I now have about 80.3 equals x plus 2. So my last step to get x by itself is to subtract 2. So I'm going to say x equals 78.3. And then finally, for my last problem, this 2 on the front, this is my power property. So this goes up and becomes an x squared. Then I have plus. So I'm going to rewrite this as these two things multiplied together. So remember, plus goes hand in hand with multiplication. So x squared times 6 is 6x squared. So now I have natural log of 6x squared equals 4. So now, if you will notice, very, very similar to problem number 7. So again, go ahead and pause the video and give this a try and see if you can solve it. I'm going to put in my base of e. I'm going to use bay. So I've got e to the fourth equals 6x squared. So now e to the fourth. Then I have to divide by 6. Then I have to take the square root. Okay, so hopefully you guys remember some of those properties. And like I said, if you don't, feel free to go back and look at some of the previous videos that I posted that go over the properties. I'll have a practice page to go along with this as well that you'll find on Google Classroom.